Okay, so we're going to be talking some structural losses with Nabi Guderzi, who's a forensic structural engineer in our Ottawa office. Nabi has over 10 years of professional practice. He's a professional engineer in Ottawa, Alberta, and Atlantic Canada. He investigates and provides repair schemes for damaged and under-designed structures and conducts structural investigations on industrial and commercial buildings. He's investigated more than 140 CAT files, including the assessment of damage to houses caused by Hurricane Dorian in 2019, BC flooding in 2021, which Eduardo had referenced, the Ontario-Quebec windstorm in 2022, and Hurricane Fiona in 2023. So yeah, Nabi, please take it away.
Thank you, Mark. Okay, good afternoon, everyone. So in this presentation, I'm going through some examples of the damage that we typically see in CAT files or in different extreme natural disasters. Here, I'm going to show you some examples of the damage we saw in during the derecho of May 21, 2022, Hurricane Fiona in September 2022, Ottawa thunderstorm on August 10, 2023, tornado in Barrie on July 15, 2021, and we're going to propose some necessary code upgrades that we think should be implemented. So first, the ratio of May 21, 2022. The destruction from a derecho can be similar to that of a tornado, but it's typically in one direction along a fairly straight path. The derecho on May 21, 2022 affected the Quebec City-Windsor corridor. It was described by meteorologists as a historic derecho. It brought winds of about 190 km per hour, and the path extended for about 1,000 km. So here you can see the map and showing the path of the derecho of 2022. It extended from about London to all the way Quebec, and it had a very straight path. And here in this image, I'm showing the path in Ottawa. 3 cities across southern Ontario declared state of emergency. Power outage affected 1.1 million customers. Hydro Ottawa described the damage to its power distribution system as more severe than 1998 ice storm. The insured damage amounted to about $1 billion. So we had many files in Ottawa and also across Ontario. Of course, as you can imagine, a lot of them included tree impact to houses and cottages. So this one, for example, it occurred in Parham, Ontario. Cause of loss, of course, tree impact, and it was extensive damage to roof and porch structure. The safety concern was it had to be shored immediately, but of course, in this case, because it was empty, it could just be left empty and restricted access, with restricted access. Here I'm showing the damage to the roof structures. As you can see, the roof joists and roof sheathing are extensively damaged. Now, here I'm going to show you some typical rules or some rules of thumb about shoring of structure when it's affected by tree impact. So here I'm showing a section of a house or the roof of a house framed with trusses. Let's say the top cord of the truss is damaged by tree impact. And also the wall is also, let's say it's damaged. So the contractor should install a shoring wall below the panel point. And the top plate of the shoring wall should be fastened to the bottom cord, and they should install 2x4 web bracing at 4 feet on the web members, and to stabilize the trusses. Now, a lot of times, if there is prolonged shoring required, that there needs to be, so the shoring needs to be there for a couple of months. So many roof structures sustain tree impact damage during fall, and in most cases, repair cannot be completed before winter. Usually, insureds want to continue to live in the dwelling, and adequate shoring is a must to ensure safe conditions under snow. Closing any physical holes is also important to prevent further damage. Now I'm showing some typical examples of prolonged shoring if the shoring is to stay there for a couple of months until the repairs can be started. Now, this is showing the section of a roof framed with rafters, and let's say there is some limited damage to roof rafter. And it needs to stay there for many months, and also there's holes in the roof. So they should install shoring wall under the roof rafter, and the shoring wall needs to extend all the way down to basement and also all the way up to the rafter. And the location of the shoring wall should be just below the small crack that is observed in the roof rafter. And of course, over the roof, they need to install plywoods and framing and install proper roofing membrane to stay there during winter. Now you can see that this shoring wall is making inconvenience for the residents here. So the other way is to install shoring posts and install blind beam above the ceiling joists. And of course, there should be blocking between the shoring post and the blind beam. And above the blind beam, they can install their knee wall to support the rafter. Now, if the damage is very extensive, like a rafter is maybe broken in the middle or something, they need to install shoring walls on both sides of the location of that crack. And of course, they need to be extended all the way to the rafter and down to the basement. Now, when it comes to tree impact, as you saw in this particular example, a lot of times the porch gets damaged. Now, here I'm showing an example of a porch, and I'm showing the section of the porch. Let's say the corner post is damaged and the deck is damaged, and they cannot install vertical shoring under the beam. So what they can do in this situation is install diagonal shoring at minimum 75 degrees. At the top, they need to install cleats around the beam to properly support the beam, and also to prevent the shoring post to kick in. At the bottom, they should prepare the ground for a proper firm support for the post, and also they should put bearing pads, and they should be secured to the ground by spikes, and behind the bearing pad they should put stakes into the ground. At the bottom of the post, they need to install folding wedge to ensure firm and full contact between the post and the bearing pad. For bearing, they can use outrigger pads or build their own pads using 12-inch by 12-inch or 16-inch by 16-inch pads. Now, this depends on the bearing capacity of the soil. For softer soil, they should use 16-inch by 16-inch. For stiffer soil, they can use 1 foot by 1 foot. The pads can be constructed of 3 layers of exterior grade, 1/2-inch to 3/4-inch thick plywood sheets. The total thickness should be at least 1.5-inch, and they should be secured with number 8 1.5-inch long structural screws spaced in 4-inch by 4-inch pattern with a 2-inch edge distance. Now, it is very common that when we go to site to inspect the damage, we see that the contractor has not installed any shoring to support the beam. So in this situation, I'm just telling you just to be aware that when there is tree impact and there is damage to corner post, because the restoration companies usually are the first people who are on site, they need to be aware of this and they need to install shoring post, either shoring post, diagonal shoring post, or needle beam. And we're going to talk about needle beam later on in this presentation. Needle beam is they put beams under the beam and they put posts on both sides of the broken post. Again, it is there are situations that we've been to site and the contractor neglected to install shoring between the ceiling joist and the rafter. So there was a tree impact to the rafter or the truss, and the contractor installed a shoring wall under the ceiling joist, but it was not extended to the rafter. So technically it was no good. Now, this is another example of roof damage during Hurricane Fiona. It was in Ottawa, cause of loss was wind. The derecho blown off the roof sheeting and shingles. And we looked at the attic as well, and there was no hidden structural damage to roof trusses. And this is very important as the role of engineer. When the engineer attends the site, of course, there's some obvious damage that can see from afar, but the engineer should always look into the attic or try to look into hidden spaces to see if there is any hidden damage. And if it's covered by some drywall or something, the contractor needs to partially remove the drywalls around the obvious damage for the engineer to be able to see if there is any damage to the structural framing. Now, in this condition, there was no damage to the trusses except for the lookouts. Now, it's worth mentioning that the lookouts of this house was not adequately fastened to the gable wall. So it was just, some of them were just bearing on the gable wall or just one nail to the gable wall. And so when that happens, when just one of them pulls apart, the wind can easily get in under the sheeting and just lift the sheeting. The other interesting thing for this file was that only this house incurred roof damage in that neighborhood. And this can happen in tornadoes or derechos because you have downbursts. As for safety concerns, for these situations, it's very important to protect the house from water ingress. So they should immediately cover the holes and put tarp or roofing membrane on top. Now, initially here, the contractor did not install the tarp properly. Here's another view of the house. So this was a tarp that was installed initially by the contractor. Now, I'm looking into the house, under the tarp, you can see that there are some holes here. You can see some holes, and for days, water penetrated the house and caused further damage to the interior finishes. So this is to show that how proper restoration effort from the get-go can prevent further damage down the road and reduce the insurance cost. Now, common shoring mistake. So let's say there's some few cracked or broken rafters and there's a hole in the roof, and repairs are not likely to happen before winter. Placing a sheathing board over the hole is an insufficient closure, or putting a tarp. It is very common, especially during natural disasters, large-scale natural disasters, that not all houses can be repaired promptly, and they usually stay there over winter. So if they just put a sheathing there or just put a tarp over the hole, that's not enough. What they should do, they should install proper framing over the existing rafters. And of course, the framing should be wide enough to cover, to sit on sound, sturdy rafters or top cords of trusses. And then they should install the sheathing over this framing. And of course, over that, they should install roofing membrane. Now, here's the other example of roof damage during the derecho. It was in Ottawa. The damage was blown off roof sheathing of the house. And also the wind blew off the entire roof structure of the garage. It was metal plate connected trusses. I looked in the attic, there was no damage to the structural, to the roof trusses. As for safety concern, again, it was important to protect the house from water ingress. They did a good job for that. They immediately installed roof sheathing and tarp. But for the walls, they need to install bracing to support the freestanding walls of the garage, or demolish the freestanding walls of the garage immediately. And that's a big safety concern. The owners were still living in the house, and the walls of the garage were left like this for a couple of days, and that creates a safety concern. Yeah, so freestanding walls of garage were unbraced for a couple of days. Here's another view showing the gable wall and the walls of the garage. Now, this is specifically a safety concern if it's brick, because it's very unstable and it's heavy. Now, with the roof, of course, on top of it, they have lateral support, but without the roof, they don't have the lateral support. Now, to brace the brick veneer, they can install the bracing on the outside. They need to place diagonal bracing, 2x6, 2x6, 2x8, depending on the design. And these braces need also their own lateral bracing. They need to install cleats at the bottom of the lateral bracing to prevent the bracing from kicking out. And of course, they need to be secured to the ground using tenon bars into the ground and embed by 2 feet. And here's is a detail of the support or the cleat at the bottom of the diagonal bracing. Here, they need to install wedge, again, to ensure full and firm contact with the cleat. And as I said, the cleat needs to be secured to the ground by tenon bars. And also there are some stakes or tenon bars that needs to be installed behind the cleat. Again, it's all there to secure diagonal brace from kicking away from the wall.
Oh, now I think you just lost sound.
Oh,
Oh,
do you hear me now?
Yeah.
Oh, okay. Sorry.
Yeah, just for a second.
Pause it for a second. Okay. So here's another example of a bracing of the wall for if the wood roof framing is blown off. Now this is the same situation. Now this is the bracing from inside. So if you are bracing to the concrete slab, you can put the bottom plate anchored to the concrete slab and brace the wall from inside. And of course, you need a ledger board screwed to the wall studs, and then you install your diagonal bracing. Now, our file here was about a garage with the roof blown off. Now, let's say you have a house and the second floor, the roof is blown off and you need to diagonally brace the wall of the second floor. Kind of the same situation, except that here you really don't want to brace from outside because then the diagonal brace need to go from the second floor all the way down to the ground. So you brace it from inside. So very similar to what you had before in the previous slide. So you put your diagonal brace here with the bottom plate, which is, they should be nailed down to the existing floor joists. And of course you have the lateral brace for the diagonal braces here. Again, this is to prevent buckling of the diagonal brace. And this is a view of the bottom of the diagonal brace. As you can see, the diagonal brace should be notched like this to, and then kind of bear vertically and horizontally on the cleat at the bottom of the diagonal brace. Again, so this is to prevent the diagonal brace from kicking out. Bear in mind that if you just put the diagonal brace just on top of the bottom plate and just toe nail it to the bottom plate, the nails can deform and the bottom of the brace can slowly move out, and then technically the bracing scheme will not be efficient. Now, again, it's a common mistake I've seen a lot of times, that the roof has been damaged either by wind or fire or anything, or tree impact, and the walls are freestanding and the contractor has not installed any diagonal bracing. And understand that sometimes they're just waiting for investigations to proceed, but they should immediately install some diagonal bracing to support the walls. And if they don't want to do that, at least install a tape around that area to restrict access to that structure and around that structure. It's just that they need to be aware that these walls are unstable. The other natural disasters that I want to talk about is Hurricane Fiona of September 2022. It was the 10th most expensive natural disaster in Canada measured by insurance payouts, caused $660 million in insured damage. Of that, $385 million was in Nova Scotia, $220 million in PEI. It was the most costly extreme weather event ever recorded in Atlantic Canada. And most of the people affected were located in high-risk flood zones where residential flood insurance is not available. Hurricane Fiona knocked out power to more than 500,000 customers. It created winds of exceeding 100 km/h, torrential rainfall, flooding, and downed trees, and it washed 20 homes in the ocean, most in Port au Basque. And this is one of the examples of soil erosion under a house. This is one of the most severe cases that I had for this event. It was in Cape Breton. Cause of loss was waves. We were asked by the insurance company, was it wave or was it wind? So the wind cannot cause this much erosion alone. Plus, if the wind was cause of erosion, we would have seen some shingles at least blown off. So the damage was erosion of soil, and it toppled some concrete piers. As for safety concerns, access must be restricted in these situations. You can see another view of the soil erosion under the house and the toppled piers. Now, as I said, there was no blown off shingles, and so the soil erosion was by waves, and yeah, I cannot even say wind was any factor in this soil erosion. The other example for Hurricane Fiona was roof damage and soil erosion. It was in Louisbourg, Nova Scotia. The cause of loss was wind and flood at the same time. Wind was responsible for the damage to the roof, as you can see, and there was some soil erosion in the crawl space, and I'll show it to you. The damage included blown off roof decking and shingles and soil erosion. As for safety concern, protection of house from water ingress was important, and the access should have been restricted due to excessive water damage to interior finishes and also soil erosion. I'm showing a closer view of the blown off decking and the roof structure per se. Now you can see that there was also a lot of water damage from before on the roof structure. This was a very old house. I'm showing the crawl space. You can see extensive soil erosion. You can see this pier and soil around it is washed out. And here you can see this toppled pier under the roof joists. The other example, again, roof damage due to downed trees. It was in Glace Bay, Nova Scotia. The damage included the damage to the decking and extensive damage to the deck, and water damage due to water ingress. So, of course, there was large-scale damage during Hurricane Fiona. Contractors were busy. They couldn't get to all files immediately, so the tree was there for a long time. No tarp was installed, so the water was just dripping into the house, and so it was extensive water damage after the tree impact. Safety concern, protection of house from further water ingress, and asbestos abatement. Old houses like that were built around 1980s, it's very likely that asbestos was used in their building materials. And here, the contractor had partially removed interior finishes and caused asbestos disturbance. It's just in these situations, when you know that the house is old, you need to be aware of how you want to remove the finishes. Just there are guidelines to safely remove finishes. If you want to do it safely, they need to follow those guidelines on it. Yeah, but here, unfortunately, they missed it. So they had partially removed the interior finishes, and then they tested for asbestos, and it came positive, and they had already disturbed the asbestos. And the occupants were coming in and out to get their stuff, which is a safety hazard. Unfortunately, it happened in this case. Here's another view of the tree impact to this house. As you can see, some decking damage to the lower roof as well. Now, This is another example. This is in Montague, PEI. The damage was cracked foundation walls. I'm showing this because this damage was not caused by Hurricane Fiona, although it was blamed on Hurricane Fiona when the claim first came in. But the damage was really due to foundation settlement and lateral pressure of soil. And the damage included cracking, extensive cracking in concrete block foundation walls. And as for safety concern, they had to install diagonal bracing against the foundation walls to prevent further damage. And we provided instructions and drawings for that. And this is a view of the cracking in the foundation walls. Now here, I'm gonna point out the color differences between different areas of the mortar. So you can tell that these are pre-existing damage, and there were some pre-existing cracks that were filled up by mortar. So these are pre-existing condition and not related to Hurricane Fiona. Another example of damage during Hurricane Fiona, it was a shifted shed. It was in Wellington, PEI. Cause of loss was flood and wind. The damage included a shed that was shifted by 2 feet, and the rear deck was damaged by flood and wind, and the handrails were damaged by wind, and they were removed. And as for safety concern, no serious safety concern except that the handrails needed to be installed immediately. And of course, the shed needs to be pushed back in place. Of course, it's not a safety concern. A view of the shed that was shifted by 2 feet. The other natural disaster was Ottawa thunderstorm on August 10, 2023. According to Environment Canada, 100 millimeter of rain was recorded in Carlton Heights and the Riverside area. The rainstorm caused 1 in 100-year flooding. It caused basement flooding and damaged at least 486 homes. This is one of the examples that we had. It was partial collapse of a foundation wall in Ottawa, Ontario, and it caused a concrete block foundation wall of the house to partially collapse in. As for safety concern, the floor joist needed to be shored up, and the brick veneer needed to be supported. I'm showing the shoring of the floor joist. So this is the wall that was damaged or partially collapsed, and the floor joists were sitting on this wall. A closer view of the concrete block foundation walls. You can see the bottom of the wall was collapsed inward. And yeah, this is a closer view. You can see the bottom is closed. You can see the top part of the wall is in place. So they had to install the shoring that you saw in previous slide. Now here you can see needle beams to support the angle, and the angle is to support the brick veneer. The reason is that the brick veneer is sitting on the concrete block wall, and of course it was partially collapsed, so they needed to install needle beams. So you have shoring posts here and another set of shoring posts on the interior, and they install needle beams. Another view, and this is the angle to support the brick veneer. Another view from inside. Now, here I want to talk about needle beams. So in situations where there is damage to the foundation wall or partial collapse of the foundation wall, they should use needle beam that extend from inside to outside of the foundation wall, usually 3-ply 2x8 needle beams, or they can be aluminum needle beams, eye-shaped. As you saw in the previous slides, the posts should be 6 feet apart maximum, Here you can see a section of the needle beam, and here you can see the wall below the needle beam, which is collapsed, and the part of the wall above the needle beam. And here you can see a set of shoring posts inside the house and a set of shoring posts outside the house, and there should be 4 feet apart maximum. What contractors usually do is sometimes they install shoring posts inside the wall, which is not really, it's in the way of working. Another example that I'm going to talk about is the tornado in Barrie. It was EF2 scale hurricane, and it produced winds of about 210 km per hour. 110 homes were damaged, and the track of destruction was 12 km long and 600 meter wide path of destruction. Here in this example, the house was in Barrie, and it caused shifting of second floor wall. It damaged the brick veneer and blown off shingles. Here's another view of the same house, and also you can see the shifting of the second floor wall. And of course, as for safety concern, they had to brace the wall of the house. Now, I'm giving some typical shoring instructions to support the floor joists if there is any damage to the wall. So if there is damage to the exterior wall, they need to install shoring wall at maximum 24 inch from the exterior wall. Here I'm showing the section of a house. This is the roof truss. So they need to install shoring wall under the bottom chord of the truss. Again, at maximum 16 inch if the bottom chord is 2x4, and at maximum 24 inch if the bottom chord is 2x6. And we are assuming that the exterior wall is damaged by, let's say, wind or tornado. Now, the need for code upgrades. According to Insurance Bureau of Canada, average number of insurance claims due to extreme natural disasters has quadrupled since 2008. Average annual insurance coverage in 2023 was about $2 billion versus $632 million from 2001 to 2010. 10 most expensive natural disasters based on insurance claims are, you can see here, Fort Mac wildfires, Eastern ice storm, Southern AB flood, Alberta hailstorm, Toronto flood. This is the ratio. In 2022, Hurricane Fiona, Toronto flood, Ontario windstorm, and BC flood. Now, these are at different dates. Now, these are from 1998 to 2023. And as you can see, 4 of the 10 most severe natural disasters occurred since 2020. So this is alarming. So we propose that Canada needs a national flood resistant design standard similar to ASCE standard. Future codes should make tornado an extreme load case that needs to be considered by the designer to ensure life safety. Codes should adopt emerging best practices to address property and life safety issues with urban wildland interface fires. And the building codes should also increase design wind loads, make it mandatory to use hurricane tie to fasten roof framing to walls, maybe set minimum distance requirements between houses and large trees, and maybe set requirements to stabilize trees at close proximity to houses if they are large and if they are at risk of falling in a wind. So in summary, typical damage to structures in windstorms, they include shingles and sheathing and roof being blown off, tree impact, shifting of structure. In flood, you have soil erosion, damage to foundation wall, and role of engineer, give safety and shoring instructions, look for hidden damage and provide repair drawings. And we proposed some code upgrades that we think are necessary to mitigate future losses by extreme weather events. Thank you very much.
Thank you very much, Navi. Okay, this would be the time for questions. anyone has any. So we'll give everyone a couple minutes to kind of mull over everything you've said and yeah, get those questions in. Just the drop down in the control panel. And Nabby, thank you very much. That was fantastic.
Yeah, you're welcome. Thank you.
And just while we're waiting for questions, a couple of reminders. We're going to be doing, we'll take a short lunch break after this, and then we'll resume for our last two presentations of the day. But here we go. Elizabeth, tricky one. Neil, when do you anticipate code changes to be adopted, and how has this been received? Well, I think these are just sort of personal suggestions, but Nabby, do you want to talk about that a little bit?
Yes. So these are just our personal opinion on code upgrades. I really don't know when they're going to upgrade the codes, and plus right now we don't have say in the codes. But we think that some code upgrades is necessary. Yeah, unfortunately, I cannot speak to if or when they're going to upgrade the codes to address natural disasters.
The second point I just wanted to make while we're waiting for questions is I'm just going to touch on certificates, because I know people's renewals are coming up. We're going to get completion certificates out next week. There's a lot to get through, but we will do it as quickly as possible. So please just yeah, bear with us. We appreciate your patience. Okay, well, if anyone does think of questions, feel free to submit them at any time. If we can always get back to you via email if we don't answer your questions live. So why don't we take a break for lunch, and we'll be back at let's say, oh, sorry. In regards to, sorry, are you still there?
I'm here. Yeah.
Okay, great. So in regards to the pre-existing damage to the concrete foundation, how could you separate it from the damage that is new?
So in that particular fire, it was all we considered it all caused by previous conditions. First of all, we didn't see any other damage that was related to the Hurricane Fiona, like no soil erosion, no wind damage to that particular house. And again, everything that we saw on that foundation walls around that basement, it was clearly pre-existing, caused by foundation settlement or excessive pressure by soil, which was also exacerbated by aging and deterioration of the mortar. But there are some situations where there is damage because of, let's say, flood, but there are also some pre-existing issues. For example, the flood that is showed in Ottawa, that the foundation wall partially collapsed in. So that wall was not, so it was an old house, first of all. It was not parched and waterproof properly. And there was the issue of mortar deterioration as well. So it all adds up. Now, it's very hard to really separate what caused, was it the pre-existing conditions or the flood that caused that to collapse? because it was an extreme flood. But my experience with, let's say, BC floods, for example, was all houses with proper foundation, let's say with proper concrete foundation, with proper waterproofing and proper depth of foundation, they were all good. There was no problem with that. But all the houses, all old houses with shallow footings, the foundations were damaged and they were toppled, and like wood, for example, permanent wood foundation walls were damaged, but all other kind of newer built houses with proper depth of foundation and sturdy concrete or concrete block foundation walls with proper waterproofing, they were all in very good condition. So yeah, I hope I answered your question.
No, I think that's a great answer. Okay, so yes, let's break for lunch or breakfast or brunch, depending where you are in the country, and we'll resume. Let's get back here for 12:30. Okay. Thank you very much, everyone, and again, Nabi, thank you. That was really great.
Thank you, Mark. Thank you all.
Okay, we'll see you in half an hour, and don't exit out. It's the same link. You don't have to leave. We'll be right back here. Okay, thank you.